Hello everyone, welcome to MindMatrix. So in this video we will be solving GATE previous year questions of year 2023 from computer networks subject. So let's start the video. So before starting, let me introduce myself, those who are new to our channel. My name is Anshul Sharma. I'm upcoming software engineer to at Juniper Networks. Currently I'm pursuing M.Tech in computer science from IIT Kanpur. I have more than 2 years of teaching experience, mentored more than 1,000 students, and I have the expertise in computer science and data science subjects. I secured All India rank 294 in GATE computer science, cleared ISRO NIC NELATE exam, also got selected as administrative officer at AIC. So let's start. And before starting, this is very important for all of you that you can join our doubt discussion telegram group. So this is the QR code. You can scan it and you will be able to join our group where you can ask your doubts. Also, we will be posting the PDFs of all our lectures that we are conducting on YouTube. Okay, let's start. So this is the first question we have, that is from GATE CS 2023. Let's read the question first. Suppose two hosts are connected by a point-to-point link and they are configured to use stop and wait protocol for reliable data transfer. Okay, so they are using stop and wait protocol. What is stop and wait protocol? So first you are going to send the data and then you are going to wait for the acknowledgement. Identify in which one of the following scenarios the utilization of the link is the lowest. So in case of stop and wait protocol, as the name suggests, first we are going to send the data, then we are going to wait for the acknowledgement of receiving the data, and then we are going to send the next data packet. Okay, so this is stop and wait. So here it is asking that we have to find out in which of the following scenarios the utilization of the link is lowest. So basically it is talking about the link utilization. Link utilization is lowest, and link utilization is nothing but the efficiency, right? Efficiency. And we know in case of stop and wait protocol, efficiency is nothing but TT divided by 2 times TP plus TT. So I'm not going to derive this formula. I hope you are aware of it, right? Because we are just solving previous year questions. So this is the formula for the efficiency in case of stop and wait protocol, where TT is nothing but the transmission time. So let me write here for you. TT is the transmission time. Okay, TT is the transmission time and TP is nothing but the propagation time. Right. And we also know that TT is TT and TP. So we can say it is equal to TT is equal to L by B, that is, or BW we can say, that is the bandwidth, where capital L denotes the packet length, the length of the packet that we are transferring, and BW is the bandwidth. And when we talk about TP, that is the propagation time, it is nothing but D by V, where D is the distance between the sender and the receiver and V is the speed. Okay, so these are the formulas. Now we need to find whether the link length should be longest or the shorter, whether the transmission rate should be higher or lower. So in which scenario the efficiency will be the lowest, the link utilization will be the lowest. So as we can see the efficiency. So this is the formula. So we can also write this like this. TT is L by B. So L by, we can write B, bandwidth here, 2 times TP is nothing but D by V. So D by V plus TT. We can write like this also. Correct. Now if you see carefully, in the options it is talking about the transmission rate and the link length. So basically link length is nothing but your D value and transmission rate is nothing but your bandwidth. So we need to find out here, if I want my efficiency to be the lowest, in that case, as you can see, it is inversely proportional to bandwidth, and also it is inversely proportional to the link length, that is capital D, right? Which means if my bandwidth is higher, or we can say the link length is also longer, in that case efficiency will be low. right? And if both are higher, in that case efficiency will be the lowest. So clearly we can say if my bandwidth is higher, right, and the link length is also higher, as the efficiency is inversely proportional to both of these, so we can say the efficiency or the link utilization will be the lowest. So if you read the options one by one, option A is saying longer link length and lower transmission rate. So is that correct? If you see here, longer link length, that is fine, but lower transmission rate, no, we want higher transmission rate. So this is also incorrect. Option B says longer link length and higher transmission rate. So longer link length and higher transmission rate, yes, this is correct. If this is the scenario, in the scenario we will be getting the link utilization as the lowest. Okay. Option C, shorter link length, no, that is incorrect. Option D, shorter link length and higher transmission rate, that is also incorrect here. So option B is the correct answer for this question. I hope it is clear to all of you. Let's proceed to the next question. Question number 2, that is from GATE CS 2023. Which of the following statements is or are incorrect about the OSPF, Open Shortest Path First routing protocol used in the internet? So this OSPF, basically it is the implementation. It is the implementation for LSR, that is link state routing protocol. So we have two algorithms, one is a DVR and one is LSR. DVR is a distance vector routing protocol, and here the algorithm, and LSR is link state routing algorithm. And OSPF is the implementation of LSR, and RIP is the implementation of DVR. So this question is based on OSPF, implementation of link state routing protocol. So now let's see here which of the following statements is or are incorrect for this routing protocol. So options A says OSPF implements Bellman-Ford algorithm to find shortest paths. And option B says OSPF uses Dijkstra algorithm to implement least cost path routing. We need to understand here, basically it is a theoretical question. So in case of DVR, it uses Bellman-Ford. And in case of LSR, it uses Dijkstra. Shortest path algorithm. So we can clearly eliminate that option A, as it says OSPF implements Bellman-Ford, that is incorrect. And we need to find incorrect statements. Okay, carefully see, we need to find the incorrect statements. So we can say option A is the incorrect statement here, but option B is the correct statement here. So we need to pick here. Option A is the incorrect statement. Let's proceed further. Option C says OSPF is used as an inter-domain routing protocol. And option D says OSPF implements hierarchical routing. So if you know the concept, in case of OSPF, it is hierarchical routing. Why? We have a set of routers here. Right? And let's say this is the border router. And here we have another layer which we call as area 0, or sometimes we call as zone 0, which is this is another layer, and then we have another set of routers here. Clear? This is the concept for OSPF. So this border router is going to transfer the information to this area 0, and then further this area 0 is going to transfer the information to another set of routers. Clear? So this is the concept of OSPF. I'm not going into too much detail. I hope you are aware of the concept. So here it is area 0, zone 0. We can say, so this is kind of hierarchical routing. Okay, so that is why option D is correct here. But it is the correct statement, but we need to find incorrect. So option C, OSPF does not use inter-domain routing protocol. So this is also incorrect statement. So let me write here for you. This is incorrect statement, and this one is incorrect statement. Okay, so that you don't get confused. This is the correct statement. OSPF uses Dijkstra shortest path algorithm, and this is also correct statement. Okay, it implements hierarchical routing. So option, if we have to find the answer, so correct answer would be option A and option C. So it is a MSQ, multi-select question. Correct answers are option A and C. Clear? I hope it is clear to all of you. Let's proceed to the next question now. Question number 3. Suppose you are asked to design a new reliable byte stream transport protocol like TCP. As we know, TCP is a byte stream protocol, right? This protocol namely named MyTCP. So we are naming this protocol as MyTCP now. And it runs over a 100 Mbps network with the round trip time of RTT is 150 milliseconds and the maximum segment lifetime of 2 minutes. So segment lifetime is given to us, that is 2 minutes. RTT is also given to us, that is 150 milliseconds. And the bandwidth is given to us, which is 100 Mbps. Okay. Now question says, which of the following is or are valid lengths of the sequence number field in the MyTCP header? We know that in case of TCP, the sequence length or the sequence number bits are 32. 32 bits are there in case of TCP, sequence number bits. Okay. Now, but we need to find in this MyTCP protocol. So bandwidth is given, segment lifetime is given, and we need to find the sequence number bits or the valid length of sequence number in case of MyTCP header. Right. Now we need to understand here, carefully see here, what is given to us. Bandwidth is given to us, that is 100 Mbps. Correct. And now we can say that in 1 second, this is very simple question. If you know the concept, you can easily answer this question now. In 1 second, 100 megabits can be transferred. That is the meaning, right? 100 megabits per second. That means in 1 second you can transfer 100 megabits, or we can write like 100 into 10 raised to the power 6 bits. Correct. The segment lifetime is given to us, that is of 2 minutes. So let me write here, segment lifetime is given to us, that is of 2 minutes, which is nothing but 120 seconds. So in 120 seconds, how many bits can be transferred? So I can I write like this, 120 into 100 into 10 raised to the power 6 bits. Now if I convert this into bytes, because we know TCP, or if I talk about MyTCP also, it is a byte stream protocol and every byte has to be count. We have to keep a track, we have to keep a count on every byte we are transferring. Clear? That's what is a byte stream protocol. So we have to keep a count of every byte. So if you convert this into bytes, you have to divide it by 8, because 1 byte is equal to 8 bits. So if you want to convert it into byte, you have to divide it by 8. So if you divide it by 8, what do you get? You can write like this, 120 into 100 into 10 raised to the power 6 divided by 8 bytes. And finally you will be getting what? 15,000 into 10 raised to the power 5 bytes. Correct? So these many bytes you can transfer in 120 seconds basically. Now, as we know in case as TCP is a byte stream protocol, so 1 byte will have 1 sequence number, because for every byte we have to keep a count. So 1 byte, that means 1 sequence number will be used. And for these many bytes, how many sequence numbers will be used? Equal to this only, 15,000 into 10 raised to the power 5 sequence numbers. And we need to find the number of bits. So to keep basically for these many sequence numbers, how many bits will be required? So can I say that sequence number bits will be nothing but, it has to be greater than equal to log of this number, 15,000 into 10 raised to the power 5, and seal of it, right? That means at least these many bits we need to keep a count on these many bytes that we have to transfer. I hope it is clear to you. It is quite simple. 1 byte will take 1 sequence number, and if we have these many bytes, so we need to find how many bits are required. So how many bits are required, that means we need to take a log of it, and it has to be ceil of it, right? That means we have to keep the upper limit, that above it at least you need these many bits, and above it also will be your correct answer, right? So if you solve this, what do you get? You will be getting 31 bits. If you solve this, you can perform the calculation. If you solve this, you will be getting 31 bits. That means you need at least 31 bits. You need at least 31 bits for sequence number, and here it is a MSQ. So anything greater than equal to 31 will be your answer. So option A 30 bits, no, it is not correct. Option B 32, yes. 34 correct. 36 correct. So BCD is the correct answer for this question. You need at least 31 bits in the sequence number field in my TCP header. I hope it is clear. I explained you the concept as well. Okay. Now let's proceed to the next question. Question number 4. Suppose in a web browser you click on the www.gate2023.in URL. Okay, the browser cache is empty, so there is nothing in the cache. The IP address for this URL is not cached in your local host. So IP address, it is not already present in the local host. So a DNS lookup is triggered. Obviously, whenever we are, let's say we are writing www.google.com. So if if IP address is not already there in your local host, in that case we need to perform DNS lookup. That means domain name system, right? We have to do that. So in order to get the IP address of that server. Now, by the local DNS server deployed on your local host over the 3-tier DNS hierarchy in an iterative mode. So this line is important here. It is talking about 3-tier DNS hierarchy. It is not just 1 tier, 3-tier DNS hierarchy is there, right? And no resource records are cached anywhere across all DNS servers, right? Now let's read the question further. Let RTT denote, I'm sorry for the background noise, guys. Okay, let RTT denote the round trip time between your local host and DNS servers in the DNS hierarchy. So you have, let's say your local host is there and you have a DNS server is there. So the time elapsed between the request and the response will be what? 1 RTT, 1 round trip time. So RTT denotes the round trip time between your local host and DNS servers in the DNS hierarchy. But if you see here, how many DNS, I mean how many tier DNS hierarchy is there? So 3-tier DNS hierarchy is there. Clear? 3-tier DNS hierarchy is there. That means 3 round trip time will be required. 3 RTT will be required here. Clear? The round trip time between the local host and the web server hosting www.gate223 is also equal to RTT. So between your local host, so first you need that IP address. So 3 RTT will be required, right, to get the IP address, this by using DNS lookup. Then you need to between the local host and the web server, again it takes 1 RTT. It is same. Fine. Now the HTML file associated with the URL is small enough to have negligible transmission time and negligible rendering time by your web browser. So for the HTML file which is associated with the URL, so it is not having any transmission time or rendering time, that is negligible, right? Now but in that base HTML file, it references to 10 equally small objects on the same web server. So basically, let me explain you in a easy way. When you request for a HTTP web page, okay, so on a web page you will be having some images, you will be having buttons. So each button or each image will count as one object. Got it? Similarly, here it is talking about the HTML file, the base HTML file basically, which is associated with the URL, the home page we can say that you are requesting. It is referencing to 10 further small equal objects. on the same web server. Okay. Now the question says which of the following statements is or are correct. Again, it is a MSQ question about the minimum elapsed time between clicking on the URL and your browser fully rendering it. So how many you have to basically, in terms of RTTs you have to find out the minimum elapsed time between the clicking on the URL and your browser fully rendering on your display. You need to find that. I hope the question is clear to you. Let's see the options now. So here the first option says 7 RTTs in case of non-persistent HTTP with 5 parallel TCP connections. Option B says 5 RTTs in case of persistent HTTP with pipelining. Option C says again non-persistent HTTP, and option D says in case of persistent HTTP. That means options are talking about 3 terms here. First of all, the major 2 categories is, it is talking about non-persistent. Now we need to understand this also. Non-persistent HTTP and persistent HTTP. So there are 2 types of HTTP we can say connections. Okay. In case of persistent HTTP request or in case of persistent HTTP, basically you need to have just one connection and you can transfer multiple objects over that single connection. Getting it? In case of persistent HTTP, you need to have just one TCP connection. And over that one single TCP connection, you can transfer multiple objects. But in case of non-persistent HTTP connection, right, in that case you need to have, or we can say one TCP connection can transfer at most one object. You cannot transfer more than one object in case of non-persistent HTTP. I hope the classification is clear. First is what is persistent HTTP. Over a single TCP connection, you can transfer multiple objects. But in case of non-persistent HTTP, over a single TCP connection, you can transfer at most one object, not more than that. Okay. Now, in the options, it is also saying in case of persistent HTTP with the pipelining. Okay, in case of persistent HTTP with the pipelining, what is the meaning of pipelining here? So basically, pipelining says that a new HTTP request could be sent to server without receiving the acknowledgement. You have sent one request, okay? Now, without receiving the acknowledgement of this request, you can send another request. That is pipelining. One after another, you can send the request. That is persistent HTTP with pipelining. Clear? You don't have to wait for the acknowledgement. Simple. Fine. Now, so we need to answer this question. How many RTTs will be required in case of both persistent HTTP and in case of non-persistent HTTP? So let's understand here. See, first of all, 3 RTTs will be required for DNS. Now, first of all, let's talk about persistent one. Let's talk about persistent one. Okay, persistent with pipelining. So 3 RTTs for DNS. As I explained to you, it is a 3-tier DNS hierarchy mentioned in the question as well. That's why it is 3 RTTs. Okay, because for one we can say, as it is mentioned in the question, from localhost to DNS server, 1 RTT is required, but there are 3-tier DNS hierarchy, so 3 RTTs are required. Clear? 3 RTTs are required. Then what else? Then after getting the IP address of your web server, you need to maintain the TCP connection. You need to establish the TCP connection. And in order to establish TCP connection, you need 1 RTT, TCP connection establishment, we can say. Right? 1 RTT will be required, right? It will take 1 RTT, 1 round trip time for TCP connection establishment. You know what is TCP connection establishment? Uh, let's say this is your client, three-way handshaking basically, and this is your server. So first you are going to send the SYN package. This is going to send the SYN plus acknowledgement, and it is going to send acknowledgement again, but it is going to be it is going to use piggybacking, right? Piggybacked, right? And acknowledgement, basically you are going to transfer the data also. I mean, you are going to get the this acknowledgement will be transferred along with the request, not the data, along with the request. So if you see, one RTT is required, one round trip time is required, that means SYN for this request plus this SYN plus acknowledgement. So one RTT is required here for TCP connection establishment. I hope it is clear now. Then what else? So TCP connection is established. Now what else? Now we have to request, basically here in the question it is saying the HTML file is associated with the URL. So first we need to get that HTTP base file. So we are going to request for it. So we are going to request the HTTP base file, and then we are going to get that. So it takes one RTT again. So for HTML base file, one RTT is required. And then what about the objects? This HTTP base file, this HTML base file, not HTTP. Yes, this HTML base file is associated, or it references to 10 equally small objects, right? And you are going to get that from the server. So finally one RTT you need to get that, to get those objects. So again, a request will be transferred to the server, and then the response you are going to get, that means all the 10 objects you will be getting, because it is a persistent connection. So in case of persistent HTTP, you will be getting all the 10 objects over a single TCP connection. You don't have to maintain separate TCP connections for every object. Clear? So one RTT you need for transferring all the 10 objects. So that's it. So how many RTTs are required? 3 plus 4 plus 5 plus 1, that is 6. 6 RTTs, 6 round trip time it will take in case of persistent HTTP with pipelining to render these objects, or to render basically the complete web page on your display. Clear? Now let's talk about in case of non-persistent. In case of non-persistent, see, 3 RTTs definitely you need for DNS connection, DNS resolution, because you need IP address, right? And you have 3-tier DNS hierarchy, so 3 RTTs are required definitely for that. What now? Again, you need to establish the TCP connection also. That is also same, nothing different. TCP connection establishment, 1 RTT will be required for TCP connection. Now, for getting the HTML base file, like we did in case of persistent also, so 1 RTT is required for that HTML base file, right? Now we want those 10 equally small objects also. We want those 10 small objects as well, but it is a non-persistent connection. So as I told you, in case of non-persistent connection, for a single, over a single TCP connection, you can transfer at most 1 object. So if you have 10 objects, how many connections you need to maintain? 10. But in the option it is talking about parallel TCP connections. So it can have 5 parallel TCP connections, it is saying. That means at a time maximum 5 objects can be transferred over 5 TCP connections. Correct? One TCP connection can have at most 1 object, if you have 5 TCP parallel connections, that means 5 objects can be transferred over each parallel connection, right? And we have total 10 objects. In case of 5, these 5 objects can be transferred parallelly. That means only one RTT will be required for that. Only one RTT will be required for that. And we have total 10 objects. So again, one RTT will be required for that, for transferring another 5 objects. Clear? So we need to maintain TCP connection. Basically 5 TCP connections will be established parallelly. So we need one RTT, and then 5 objects will be transferred parallelly. So we need one RTT for that. Similarly, again TCP connections will be established, 5 TCP connections parallelly. So we need one RTT for that, and the remaining 5 objects will be transferred. That also needs one RTT. This is the scenario. I hope it is clear. Let me explain you again in case of non-persistent. First we need to make the DNS resolution. So 3 RTTs are required because it is a 3-tier hierarchy in case of DNS as it is given in the question. Then we need to maintain the we need to establish the TCP connection, right? Then that takes one RTT. Then to get the HTML base file, we need one RTT. Then we can have 5 parallel connections. So in order to establish 5 TCP parallel connections, we need just one RTT, because at a time 5 TCP connections can be maintained, right? Like this, you can imagine like this: 1 2 3 4 5 TCP connections can be maintained, right? And over every TCP connection we can transfer one object. So one RTT will be required basically, because at the same time 5 objects will get transferred. Again, for the remaining 5 objects, again you need to maintain a TCP connection. So that takes one RTT, 5 parallel TCP connections, and to transfer 5 objects parallelly over these 5 TCP connections, you need one RTT. So how many total RTTs are required? So 3 4 5 6 7 8 9. So 9 RTTs are basically it is required in case of non-persistent. So the correct option, if you say option A 7 RTTs, no. Option B says 5 RTTs in case of persistent, no. 9 RTTs in case of non-persistent HTTP with the 5 parallel TCP connections, yes, option C is correct. What about option D? 6 RTTs in case of persistent HTTP with pipelining, this is also correct. So option C and D are the correct answer for this question. I hope it is clear. Let's proceed to the last question. Question number 5 from GATE CS 2023 Computer Network subject, and this is based on IP addressing. The forwarding table of a router is shown below. Okay, so we have a forwarding table for a router that we maintain basically for a router. That is given to us. Subnet number is given to us. Subnet mask is given to us. Interface ID is also given to us. Clear? Now, the question says a packet addressed to a destination address. So there is a packet and its destination address is given to us, which is 200.150.68.118 arrives at the router. So this packet arrives at the router. Now the router has to decide it will be forwarded to which interface ID. So we have interface ID as 1 2 3 4 and default as well, which is 0. So the router has to decide to which interface ID this packet has to be transferred. In order to decide that, there is a procedure. And what is that procedure? Let me explain you first. So basically destination address is given to us. Let's say it is D. Destination address is given to us for that router. Now this destination address, you have to take the bitwise, you have to perform the bitwise AND operation. You have to perform the bitwise AND operation with the subnet mask. You have to perform the bitwise AND operation with the subnet mask, right? That means first for this destination address, you are going to perform AND operation with this subnet mask. then you are going to perform with this one, then you are going to perform with this one. That means with all subnet mask one by one, you are going to perform the bitwise AND operation. And the result of that, if it matches with the subnet number given here, if it matches the result of that, if it is matches with the subnet number given to given here, let's say if it matches with just one, let's say for example, it matched with the first subnet number and it is not matching with other subnet numbers. So that means it is quite clear that you have to transfer that packet to the interface ID 1. In that case, let's say another scenario where it is matching with more than one subnet number, then what to do? If it is matching with more than one subnet number, in that case we need to compare the subnet mask. The larger the subnet mask, if the larger the subnet mask, that means that to that interface ID we need to transfer the packet. Okay, and how to decide which subnet mask is bigger or larger? The subnet mask which is having more number of ones, the subnet mask which is having more number of ones given, right? So to that interface ID we will be transferring the packet. And if it does not matches with any of the subnet number, in that case we will be transferring that packet to default. That means we are going to transfer the packet to interface ID 0. So there are three cases. Again, I'm explaining you all the three cases. We have to take the bitwise, and we have to perform bitwise AND operation between the destination address and the subnet mask, which with each of the subnet mask given here. Now, if the result of this matches with only one subnet number, simply you have to transfer the packet to that interface ID. Second scenario, when it matches with more than one subnet number, in that case you have to transfer the packet to that interface ID which is having the larger subnet mask, the largest subnet mask. And largest subnet mask means more number of ones in the subnet mask. Clear? And the third scenario will be when it is not matching with any of the subnet number. In that case you are going to select this default subnet number. That means you are going to send that packet to interface ID 0. Clear? Now let's solve this question. The first scenario, so here it is, let's talk about the first one. So 200, it is 150.68.118. You are going to perform bitwise AND operation, and with the subnet mask, let's say for first subnet mask 255.255.0.0. So what do you get? If you are performing bitwise AND with 255, that means all ones you will be getting same as it is. So 200.150. What about this one? So here you will be getting, you are performing, here it is 0, right? So you'll be getting 0 only. This is what you are getting. Now we have to match with the subnet number. It is 200.150.0.0. It is matching? Yes. So we can say it is matching. So matched. Let's see the second one now. So destination address is same, right? 68.118, but the subnet mask changes. Now we are going to perform bitwise AND with this subnet mask. So 255.255.224.0. Right. So I hope you know how to perform bitwise AND operation, right? Like for example, let's say it is given 0101, and I want to perform bitwise AND operation here with 1011. So if it is both 1, I will be getting 1 as the result. Here 10, if you perform AND operation, you will be getting 0. Here it is 0, here it is 0. If both bits are 1, then it is 1. If any of the bits is 0, it is 0. If both are 0, then also 0. Clear? Basically AND operation. Clear? So similarly, you can convert this decimal into binary and then you can perform. So I'm writing it. You can do the calculation, right? It will be same, because it is 255, so 200.150. What about this? So here you will be getting what? This is going to be 64.0. Okay, you can perform the calculation, convert 68 and 224 into binary, and then take the bitwise AND. Okay, you will be getting 64 here. So is it matching? Yes, it is also matching. So we can say it is matched. It is matched. What about the third one? So here it is 200.150.68118, and the third subnet mask is 3 times 255. This is simple. 3 times 255 and 0. So here you will be getting 200.150.68.0. Is it matching? Yes, it is also matching. So we can say it is matched. What about the fourth one? Let's do it. 68.118. Fourth subnet mask is, okay, 3 times 255. And here you have 224. So if you do this, what do you get? This is exactly 200.150.68, and for this one you will be getting a 96. Okay, if you perform bitwise AND operation between 118 and 224 in binary. So if you convert that back to decimal, you will be getting 96. Okay, is it matching? No, it is not matching. Here it is 64, but we are getting 96, so not matched. Fine. So as I explained you 3 scenarios. Now second scenario is true here. That means it is matching with more than one subnet number. It is matching with more than one subnet number. So in that case, we need to find out the largest subnet mask, and we can clearly say largest subnet mask is, that means which is having more number of ones, more number of ones in the subnet mask. So if you see here, if you see carefully, here it is 255, 8 ones plus 8 ones, 16 ones here, right? What about this one? 8 plus 8, obviously it is 2 to 4, that means more than 16. In this case it is maximum 8 plus 8 plus 8, 24 ones, right? And this is not matching, so this you can eliminate directly. It is not matching. We have to compare among these 3. So this is, third one is having 24 ones, maximum ones. So we need to transfer this packet to interface ID 3. We need to transfer this packet to interface ID 3. So option, I mean, in this is a numerical answer type question, NAT. You need to enter the input integer value here, which is 3, and that is your answer. I hope it is clear to all of you, right? So that's it from this computer network GATE 2023 previous year questions. And you can join our doubt discussion telegram group. You can scan this QR code, you will be able to join it. I will be posting the PDF of this lecture also in my doubt discussion telegram group. You can join that and subscribe, like, share and subscribe to MindMatrix YouTube channel. And you can also join our WhatsApp channel, and link is also directly given in the description of this video. You can join from there, right? So like, share and subscribe to MindMatrix. And on 15th of January, don't forget, we are going to give you the biggest surprise for both GATE Computer Science and GATE DA. So it will be a big day for all of you as well, for GATE aspirants, all the GATE aspirants. So thank you everyone. We'll see you in the next video. Take care. Bye-bye.